Okay.
This call is now being recorded.
So this was a data set which we have seen for the previous classification algorithms as well, right? So the same thing: user ID, gender, age, and estimated salary, and purchased, or whether he or she has taken that offer or not, yes or no kind of, right? Yeah. So as we have discussed, like we need only age and estimated salary columns, which are very important than compared with user ID and gender. For this value, Y purchased. So we'll divide that X and Y's. Yeah. So by using our slicing process, yeah. So X-ray now it contains only the age and estimated salary, and Y contains the yes or no statements. I mean the yes or no column, the purchased. Okay, now we can from sklearn dot model selection train test fit. You can do the train test fit process, right? Yeah. So I applied my train test fit, and then I need to apply my standard scaler as well because age is a small value compared with the salary, so machine will ignore it. So instead of ignoring it, now we need that column. For that sake, we are bringing down the age and estimated salary to the same scale, same process. Okay, fitting SVM. So instead of, yeah, what is that? Yeah, so instead of decision trees or whatever it is there, no? So we are applying SVM now here. So we are predicting the output. Yeah, if we apply the confusion matrix, yeah, if I go to CMs, if I need to find the accuracy, there are 100 samples in our test data set, right? CX test contains 100 samples. I mean 100 sample data points actually. So 66 plus 24 is our accuracy meter. It is 90. Yeah. So out of all the algorithms, what we have seen, the accuracy and all, no, for the classification methods, the KNN, K nearest neighbors, if you remember. So it has given us 93% accuracy. Yeah. So I've elaborated a point as well. After checking out the accuracy levels of all the classifications, also I told you KNN might not best suited algorithm. Okay, it is giving us 93% accuracy, but if it is not going into some overfitting or underfitting state, now that's fine. If it is going into overfitting or underfitting state, then we can go with the next algorithm, which is giving the high accuracy. So we need to check that, and we need to find the metrics for that. Actually, after finalizing the metrics and all, we can proceed with our algorithms, right? Yeah. So that's how the classification theory works actually. So classification is something where your entire output is divided into what do we say? The entire output is divided into categories or classifications, right? 1 minute, guys. I got a message. Yeah, yeah. Okay, I'm back. Yeah. So classification, you understood about classification, right? Classification is something where the output is divided into categories, kind of. Then you need to predict out that particular category, whether, for example, yes or no statements, true or false statements. Since we are learning the fundamentals, I'm teaching you with two categories only. So if the categories increases like more than 3, more than 4, more than 5, kind of, it is the same process is applicable to all the respective data sets as well. Clear. And we have seen the regression algorithms as well. Okay, I'm just giving a summary back to a supervised and a supervised machine learning process. Okay, so supervised machine learning is divided into two categories. That is, one is regression, the other one is classification. So in the regression, so regression is nothing but real-time values, where you see the output as a real-time value, kind of salary, kind of, or temperature or humidity, the output, those, yeah, the output. Yeah, so coming to classification, yeah, so these are the classification algorithms. And in the regression, we have seen simple linear regression, multiple linear regression, multilinear regression, polynomial regression, decision tree regressor, and support vector regressor, and also random forest regressor as well. Coming to classification, we have seen k nearest neighbors, logistic regression, and decision tree classifier, random forest classifier, support vector machine classifier, that's support vector classifier, right? Yeah. So we have identified which algorithm is giving us best accurate output, the prediction part, out of all the algorithms, right? We have identified it. Like we have checked the accuracy in the regression. So what is the accuracy that it is giving us? And we are checking the accuracy in the classification by using the that particular data set, right? Yeah. So this is the manual process which we are doing it. So manually you are doing it, and you're hello.
Sir, your
Yes, sir.
voice is
Yes,
not
sir.
clear, sir. Now it is clear.
Okay, I got it. I got it. So till where, no, no, till where you have like listened, like till where you have heard the topic and all.
Yeah.
Can anyone tell me?
Yes. In SV classifiers or support vector classifier, you stop. That's it.
Okay, here only we have stopped it. And support vector classifier, we have got the accuracy, this thing, and that's it.
Yes, sir. Accuracy you have told.
Okay, sir.
Okay, okay. So I was giving you the summary actually. So after that, now I was giving you the summary of regression and classification actually. Okay, so like in the regression, we have seen so many algorithms, right? So how we have defined our algorithms in the regression process, and after that, we have compared our algorithms and we have found out the best suited algorithm for that particular data set. In the same way, we have jumped into the classification, and we have seen so many other algorithms in classification also, and we have visually represented the classification in the form of graphs, right? And we have decided like which algorithm is best suited for the data set or something, right? So this is the summary what we have done so far. So the supervised machine learning process involves these kind of predictions actually, because we know the output value y, we know the output value y, and we are able to predict the outcomes. But what if you don't have the output values, that you don't have an output value, and if you want to get some insights from the data, so what you're going to do at the time, now we'll jump into the unsupervised machine learning process. Okay, so in unsupervised machine learning, we are going to learn k means and hierarchical clustering. Okay, these two we are going to learn today, and we are going to close off our machine learning sessions. Okay, good. Okay, let us start with k means clustering. Okay, so we'll have a quick summary actually. Machine learning, yeah, we already know the definition. Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience, right? So that's what we are doing. Like we are training the data set, and the training, whatever the experience it has, it is able to predict the outcome in the test set, and we are comparing the things, and we are getting some accuracies. Okay, machine learning is an application of, yeah, machine learning focuses on the development of computer programs that can access data and use it, learn for themselves. Yeah, that's what we are doing. Okay, supervised machine learning, yeah, again, supervised machine learning is something where you have a output variable y, and predict the output by using the x inputs. So the majority of practical machine learning uses supervised learning. Yeah, majority of the things we use that only. Yeah, supervised learning is where you have input variables x and an output variable y, and you use an algorithm to learn, the mapping function from the input to the output. Yeah, so like f of x. So f of x is a functional representation of input values. Based upon the algorithm whatever you are using, the formula will change there, and y remains same and x remains same. Yeah, the goal is to approximate the mapping function so well that you have new input data that you can predict the output variables y for the data. Okay, it's a goal actually. The main goal is to approximate the values whatever you get to the output, right? So that's what we have learned in statistics and all. Yeah, it is called supervised learning because the process of an algorithm learning. Yeah, you can read this, that's fine. Yeah, so this classification and regression, we have seen this. And unsupervised machine learning, yeah, unsupervised machine learning is where you only have input data x and no corresponding output variables. Will not be having any corresponding output variables here. So we get some insights from the data by using the clustering techniques. That means we are grouping down the data and all. Okay, the goal for unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. That's, yeah. So these are called unsupervised learning because unlike supervised, there is no correct answers and there is no teacher. Yeah, there is no output. That's what it meant. Okay, unsupervised machine learning can be further grouped into clustering and association problems, but we are mainly focusing on clustering problems. Clear? Yeah, clustering problem is where you want to discover the inherent groupings in the data, such as grouping customers by purchasing behavior. Okay. In the starting of the session of data science, we have discussed about the recommendation system and the Amazon. So the related products, previously it was showing you the related products, like if you're buying a mobile, it is giving you only the mobiles and all. But now if you're buying an iPhone, it is intelligently recommending you iPhone case or iPhone charger or something like that. So that means you're grouping the customers there based upon similar tastes and all, right? I'm just giving you one example there, but we'll use a different process there. But in order to make your practical understanding, I'm giving you an example. Okay, so a clustering problem is where you want to discover the inherent groupings in the data, such as grouping customers by which purchasing behavior. Yeah, so that's how the clustering works actually. Okay, we'll see. So there are two algorithms present in clustering. That is, one is k-means and the other one is hierarchical clustering. So first we'll start with k-means. We'll understand how the k-means is working, and we'll take a data set and we'll check the code and we'll execute the code, and we'll see how the output we are getting. Okay, so k-means. So k-means is used to cluster your data. It is mainly used to discover the categories of similar data in our data set. Understand this, it is mainly used to group the data points, similar data points, whatever in the data set actually. So before k-means, for example, think like this. These are our data points like this. Before k-means, we have this kind of graph. So the gray points, all of whatever the gray points you are looking at are the data. Sorry. Okay, yeah. So think like this. These are the data points which we have in the plane, Cartesian plane, that is in the x and y axis. So we don't have any output. So how we are going to group up the similar data points in a particular data set? Okay, let us see. Let us go. Okay, how many groups we can identify by looking at the graph? Okay, how many groups you can identify? This is one group, this is second group, and this is third group, right?
3, sir.
Three groups. Yeah, we're able to identify 3 groups. What if there are millions of data points out there? Then how we can't identify the number of groups, right? Then we need to leave that to the machine. Machine should understand that these entire data points can be divided into 3 groups and all. So how machine will understand? Let us see. Okay, K means take decisions easily and group similar data which are called as clusters. Okay, so the K means, so K means group the similar data points, and those similar data points which are grouped together is called a cluster. See, that's all. Before K means, if you apply this, and after K means, see the 3 data points. Sorry, the 3 groups are divided. All the data points are divided into 3 groups, and there are 3 clusters formed in this particular data set. Like by applying the K means on the particular data set, this is our output actually. So how come K means is deciding this? How come K means is deciding this? Let us see. So these are the steps actually. Choose the number K of clusters. Okay. So initially we don't know how many number of clusters we need to choose, right? So let us assume that we'll choose the number of clusters as 2. But later on I will tell you how to choose number of clusters programmatically or mathematically. Okay. But now see, choose the number of K of clusters. At present we don't know like how many clusters are required for this particular data set. So random, like I'll select K equals to 2 initially. Okay, and the second step is select at random K points the centroids, not necessarily from your data set. Like choose any data points randomly from the Cartesian plane, whatever the plane you have created in the data with the data points. Okay, we'll choose centroids in the sense like any point you take that any point. Okay, now assign each data point to the closest centroid. Okay, so after applying a centroid or something, you need to assign each and every data point to the nearest centroid. That means you can calculate the Euclidean distance between the centroid from the centroid and the data point. You can do that, and you can group that particular data point which has the lowest Euclidean distance to the centroid. You can group the data point to that particular centroid. Okay, and that forms K clusters. So likewise, assign each and every data point. How many data points are present inside our data set now? Assign each and every data point to that particular centroid which was chosen randomly. Okay. After choosing now, we'll have 2 different groups. Since we have taken only K is equals to 2, that means 2 clusters. We have 2 different groups now. Clear? Okay. Now what I will do is I'll identify new centroid. Like I'll take the average of all the data points of group 1. I'll get a point. I'll get a center point, and I'll take the average of the points of the group 2, and I'll get a second centroid. Again, I'll apply my Euclidean distance, and I'll regroup my all the data points. If the regrouping is done, then continue this process. If the regrouping is not done, like, okay, this is the thing, till here, it has finished it, then the algorithm stops there, and it identifies that it has a final step, and it proceeds further. It gives us the respective output. See, step 4, compute and place the new centroid of each cluster. Yeah, after placing the each cluster, step 5 is reassign each data point to the new closest centroid. If any reassignment took place, go to step 4. Step 4, again, create a new centroid and assign the data points and all. If any reassignment took place. If not, otherwise go to finish. So that's how the k-means clustering works actually. Okay, choose the number k of clusters. That is k is equals to 2. See, randomly we are choosing k is equals to 2, but yeah, so manually we are choosing it, but mathematically we will prove, like the how to prove, I'll show you. Okay, but yeah, randomly you can choose 2. That's fine. Initially, for small data sets and all, no, you can choose only 2. Okay, select at random k points the centroids not necessarily from your data set. Okay, now see, this is my data set. Randomly I've chosen my centroids. Randomly I've kept my centroids here. Okay, now what I will do is, see, I'll draw a line from this centroid to this centroid. I got a line here, right? I got a line here. I've got a line, and I'll bisect that line with a new line horizontally. So I got a vertical line, and I'm going to bisect a line horizontally from the new line, from the centroid to centroid, whatever the line is there. I'm going to bisect it horizontally. So after bisecting it, the entire data points is divided into this side and this side. Okay, to the line, the horizontal line, whatever the data points you have, to the line, whatever you have on the upside, that belongs to this centroid 1. To the line which are the data points on the, or to the downside, belong to this centroid 2. Okay, so after applying the like all the data points, like which are above the line, which are below the line and all, this is our new data points now. These are everything belong to one category, these everything belong to second category. Okay, this is new centroid. See, this is randomly chosen centroid. After choosing the points that belong to group 1 and group 2, group cluster 1 and cluster 2, this is my new centroid. Now again, I'll draw a line from centroid to centroid, and again I'll bisect a line horizontally from the centroid line. And if I identify that any new data points are regrouping, then I'll stop. If they're regrouping, then I'll go to the 4th step, that is assigning a new centroid again, and again doing the same step. If they're not regrouping, then I'll stop the process, and then I'll come to some conclusions. Is that clear? Everyone understood, right?
Sir, 4th step once again you explain, sir.
Okay, 4th step. See, so after applying the centroids randomly, so draw a line horizontally from one centroid to other centroid, and bisect a line. Sorry, draw a line vertically from one centroid to other centroid, and bisect a line horizontally at the center of that point of that line. So to the above of the line, what are the data points are present, that belongs to the cluster 1. To below that line, what are the data points are there, that belongs to cluster 2. Clear? So after that, I'll get a new centroid. After that, I'll get a new centroid here, right? Again, I'll do the same process. I got a new centroid. Again, I'll do the same process. If there is no regrouping, that means if any red point is shifting towards the first cluster or something like that, if there is no regrouping is taking place, then finish it. If suppose after doing this also, this red point is going into this group, that means regrouping is done there. Regrouping is happening. So again, choose a new centroid. Again, do the same process until and unless the regrouping has finished. The regrouping is not taking place. Okay, then you can come into some conclusion that, yeah, the centroids, whatever we have fixed, are fine, and the regrouping is not happening. So I'll fix with these centroids, and then we'll group the things up and we'll go to the conclusions. Clear? Is that clear? See, this was the horizontal line which I was talking about. See, the regrouping is being done here again. To this line, the blue data points have come up here, and now these blue data points will convert into red data points actually. Red data points. And after that, again, new centroids are locked up. See, again, new centroids are locked up. Again, one horizontal line is drawn. Again, the reassigning is done. See, in this, still we have a blue symbol here, right? And if you cut this down, and the red symbol is going into this blue group. So again, the regrouping is done. Again, I'll create new centroids. I'll assign this data point into this blue category. And again, my centroids, I'll create new centroids, and then again, I'll do it. So after doing everything is done, so this is my new original data set. So this is the cluster 1 and this is the cluster 2. Is that clear?
Yes, sir. It's clear,
right?
sir.
Yeah. So the same process, if you identify 3 groups like this kind of selected random k point, something like that. Okay. So choosing the right number of clusters is a difficult task. How to choose it? Okay. We have a metric for that. Metric in the sense where it gives us the particular number of clusters and all. Okay. That is called as within cluster sum of squares. Okay. The metric name is called as within cluster sum of squares. For example, think this. So we have 1, 2, 3. There are 3 clusters. We need to build 3. Like you can't randomly choose 2 clusters now, right? If you choose 2 clusters, it's of no use. I mean, the data will not be that accurate. See, this is the formula for within cluster sum of squares. Okay, so it is like the Euclidean distance, whatever you're identifying from the center to all the data points, the summation of all the points plus the second cluster plus the third cluster. Okay, then you draw a graph between the clusters and the WCSS, whatever the value you are getting from here. Clear? Like for example, if you have first take one cluster, identify the WCSS, you'll get a value. You'll get a value like this. For one cluster, I have 8,000 WCSS. Okay, and again, you take 2 clusters and identify the value. Like I got 3,000 for that. And you take 3 clusters, likewise, you go on till 10 clusters. How many clusters you want? That many clusters you apply this WCSS and identify the WCSS value. So this is called as elbow method. Okay, it's like a elbow, right? So it's like our hand elbow. So the elbow where we are bending, this is the last point where you are bending, right? So we'll consider this point as the number of clusters. Those are the optimal number of clusters which we are going to choose. That means after this, there is no need to go beyond that, because there is no variation between the data, right? There is no variation between WCSS, then there is no information variation, right? So there's no information variation. So now what I will do is I'll take the cluster as 3, number of clusters as 3. Hello? Can everyone
Yes,
hear my
sir.
voice? Sir?
Yes, sir. It's audible, sir.
Okay, I'll take the cluster value as 3 now, number of clusters. Okay, so let us check our cluster code and then we'll run it and we'll see how the output is. Okay, k-means we'll see. Before going to k-means and all, first we'll look into our data set. Okay. Okay, good. Okay, take the data set. We'll see the data set in it first. Okay, see, we have customer ID, we have gender, and we have age, we have annual income, we have spending score. If you look carefully, there is no particular column for the output. So there's a spending score, there's annual income, and there is age, and like that only. But we don't have a particular output variable actually, right? Yeah. So based upon these, what is output? Whether they are purchasing the product or what it is. So we don't know. So we can group the customers who have similar tastes and all actually by using this clustering technique. Okay. We have age, we have annual income, we have spending score, right? We'll go here. Yeah. So first we'll choose our X. Since we don't have Y, we need to choose only X. Right? Yeah, we have X. So the X is 3, 4. Okay, it's 0, 1, 2, 3, 4. There is annual income and the spending score. So based upon their annual income and spending score, you are dividing the clusters. If you want to take the age also, that's fine. You can take the age. But yeah, here we have annual income and spending score. We are taking annual income and spending score. Okay, you can consider age also. That's fine. Okay, now there is no need for train test fit and everything because we have, what do we say? We have only 200 data points, right? That's fine. So no need to standard scale as well, because no need to standard scale also. Okay, so first we'll identify the optimal number of clusters. Okay. Okay, so using the elbow method, right? We have discussed about elbow method. For that, from skl_n.cluster, we are going to apply our k-means, and WCSS, we are taking an empty list because we are going to fill the values of the WCSS, with the dynamically. Like we are taking the clusters from 1 to 11. That means 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll have the clusters, and we are applying one by one cluster to the n clusters I. Okay, in it k-means plus plus. K-means plus plus is something WCSS. You are applying the formula, right? That's the same formula, right? And you are applying the random state as 42. Okay, you are applying the random state as 42. That means at that particular point, there is no need to change any static dynamical. There is no need to change any values. If you're applying the formula again and again, make the all values as static. Okay. Okay. So let's see. I've applied it, and if I plot the plot diagram, I'll go to the plots. See, so it is giving me 2, 4, and 5. This is the fifth one, right? So after this, there is no information, particular information is dropping down, right? So 5 is the number of clusters which is suited for my data set now. Right? 5 is the, see, we are k-means.fit, we are applying the k-means to our x value, and we are applying 1 to 10 clusters, and we are identifying our elbow method. And from the elbow method, we are identifying that these many number of clusters are required for this data set. And finally, we have fixed for the number 5. Right? Number 5 is my optimal number of clusters for this particular data set. Now I'll apply n clusters equal to 5, and then we can visualize the clusters. See, so that's how the clustering works here. See, cluster 1, the red group, this is a centroid, the yellow one is a centroid. So 1, 2, 3, 4, 5 groups we have created, right? Is that right? You understood, right? Does anyone have any questions on this, or? Okay, so we'll move further, and we'll discuss on hierarchical clustering, which is the last clustering technique which we have. Hello?
Sir,
Yeah. Okay, so hierarchical clustering is used to cluster your data, same process, but it's a different algorithm actually. Okay, same thing. Whatever the k-means does, it does the same thing only. So how many groups you can identify by looking at the graph? We'll consider this agglomerative approach. We do the process from bottom to top. So we are going from bottom to top. Actually, I'll tell you what is bottom to top and all. So before HC, and this is after HC. I mean, same thing. K-means you applied, and hierarchical clustering also if you're applying. It's the same process, but it's a different algorithm. See. Okay, so this is the process for hierarchical clustering. Make each data point a single point cluster that forms n clusters, right? So we are making now each and every point a single point cluster actually, right? So it's a different process now. Previously, we have identified some centroids, and we are grouping the values. But here, you are making each and every single data point as a cluster. Like assume that each and every data point is a cluster. Okay. Okay. Step 2, take the 2 closest data points and make them one cluster. That forms n-1 clusters. Right. So that means if you're like, if there are any new 2 nearest data points, now make that as a cluster. So if you have 2 clusters now, it is reduced to 9. Right. Okay. Take the 2 closest clusters and make them one cluster. That forms n-2 clusters. Again, repeat that. Repeat step 3 until there is only one cluster, and then finish it. Okay. So step 3, after step 3, until and unless it finds only one cluster, now it's still till only one cluster is left. Do the process, and then finish after that. Okay, distance between 2 clusters. Option 1 closest points, option 2 furthest points, option 3 average distance, option 4 distance between centroids. You can use any kind of techniques to identify the nearest data points actually. Clear? Okay, let us see. Consider the following data set. So it has 6 data points, and each and every data point is a cluster now. That means our n value is 6. Our n value is 6. Good. So now make each data point a single point cluster that forms 6 clusters. Yeah, 6 clusters. Okay, now take the 2 closest data points and make them one cluster. See, so these are the 2 closest data points compared to all. These are the 2 closest data points. So we are making this one cluster. And these are the two closest data points. See, after these two are the two closest data points. We are making that into one cluster, right? After this, likewise, you repeat everything and you make sure that you have all the clusters placed in under one cluster based upon the distance and all, and you finish it. Okay, see this. So the joining, whatever you are doing now, you need to join like this actually. So I mean, after what are the process you are doing? For example, see, this is my, okay, let us assume. So these are my P2, P3, P1, P5, P4, P6. P1, P2, P3 we have. The first one is P2 and P3 are clustered into one. See, P2 and P3 are clustered into one. And P1, P2, P3 are clustered into one since they are closer. So P1 is clustered into P2, P3 cluster. Right? In the same way, P4, P5, P6 is also done. And finally, everything is made into one cluster. So these are called as dendrograms. Okay, these are called as dendrograms actually. Okay, so see, whenever you're identifying like a single line or something, when you're cutting this into, you are able to identify two clusters, right? Two clusters. I mean, this is one cluster, this is one cluster. So if you're bisecting a line of the dendrogram like this, if you're finding there's a two clusters here, then that is our output actually. That means the entire data set is divided into two clusters. Is that clear? Or if you're cutting the line here, it will change into four clusters. Right? So the largest distance, so you need to identify the largest distance and you cut that line. The shorter distance, no need to go for the shorter distance. So the largest distance, whatever, after forming the clusters at the end point, and if you're like doing this, the clustering technique and all, if you're finding the largest distance between the two clusters, then that is your bisecting point actually. Clear? That's how you do the hierarchical clustering part. Okay, let's see the hierarchical clustering also. It's the same data set. See, again, we are applying the same thing. That is what bottom to top is. From the bottom, we are going to the top, right? So that's what bottom to top process is. Okay, from import IP cluster.hierarchy, we need to import our hierarchical clustering. Okay, and dendrogram process you are using, since you are using the dendrogram process, use the dendrogram process to identify the optimal number of clusters actually. Okay, see, if I do this, oh, sorry, remove that plot also. So first we are plotting it by using the dendrogram module present in the scikit-learn package. So we'll have the dendrograms. Yeah, see. Okay, see. So now we have the dendrograms for our particular data set. So the farther distance is this one, right? If I cut this line, I'll get one cluster, 2 and 3 clusters. What happens if I cut this line? 1, 2, 3, 4, and 5. So 5 is the maximum number of optimal number of clusters which you can choose. Right? K-means also has given us the 5 value, and hierarchical clustering is also given us the 5 value. So if I apply our visualization technique here, like we are applying plot.scatter only to each and every cluster and to each and every centroid actually. The same thing. See, K-means also has given us the same thing, and hierarchical clustering also given us the same thing. So it's very crucial to identify the optimal number of. So if you are able to identify the optimal number of clusters, then it's fine. Okay, I guess that's it for today.